MS University, Tirunelveli, Tamil Nadu, going to present our work entitled Synthesis and Antioxidant Activity of Noble Chalcones Based Oxygenes and Thagenes Derivatives.
Yes, sir.
So you are welcome.
Yes.
As Abhivindu,
Yes, sir.
you can now switch to the slide mode.
Okay, sir. Can you see my screen, sir?
Yeah, I can see your screen. Just you switch on
Okay,
to
sir.
the
Shall I
slide mode.
start? Shall I start, sir?
Can you switch
Okay.
on the slide mode?
Light mode, light mode.
Slide
Now, sir?
slide mode, slide mode.
Now, sir?
From beginning. From
Yes,
beginning.
sir. Yes, sir.
Slideshow, slideshow.
Slide show. அதுலதானே இருக்கு.
Yeah, now go to the beginning.
Now, sir?
That's okay. Yeah, it's okay. Now just click it. From beginning.
Okay, sir. Okay, sir. Good afternoon to everybody. I am Abhi Bindu, Department of Chemistry, Manonmani Sundarnath.
Excuse me, please. Excuse me, please.
Yes, sir.
Please go on slideshow mode. Just click the slideshow.
Already in
click from
slideshow,
beginning.
sir. Already in
Now click
slideshow, sir.
now click from beginning.
Yes,
Very
sir.
left. Just click the icon from beginning.
Yes, sir.
Click that is below the file.
Go from beginning.
That is below the file. From beginning. Yes. Just click it.
Now, sir.
Oh, it is not still.
Okay, sir.
First,
My topic.
First you click slideshow.
Yes,
First
sir.
you click slideshow, then click beginning. Slides, yes. Now from beginning. Oh,
Okay, sir.
think it is not working. I think it is not working. So you have to move the slide manually.
Okay, sir.
You start and move the slide manually.
Now, sir.
Yeah, that's good. That's good. Good.
Okay.
It's working now.
Okay, sir.
Yeah.
My topic is
start. You can start, please.
Synthesis and antioxidant activity of novel chalcones based oxygen and thiazine derivatives. Introduction. Heterocyclic compounds, particularly 5 or 6-membered ring compounds, have occupied the first place among various classes of organic compounds for their biological activities. The heterocyclic chemistry is composed of 5-membered, 6-membered, and fused heterocycles. It is commonly reported that heterocycle having sulfur or nitrogen atoms or both of them are the general features present in the structures of most of the pharmaceutical and natural compounds. These compounds possess one or the other chemotherapeutic or pharmacological activities. Chalcones. The chalcones were synthesized by condensation of different substituted aldehydes with acetophenone through Claisen-Schmidt condensation reaction in ethanolic sodium hydroxide solution. Chalcones contain the reactive ketoethylenic group, that is CO bond CH double bond CH, a chromophore responsible for the coloring chalcones compounds depending on the presence of the other oxochromes. The compounds with the backbone of chalcones have been reported to exhibit a wide variety of pharmacological activity, including anti-malarial, antibacterial, anti-tumor, anti-cancer, anti-inflammatory, antifungal, and antioxidant. In my study, ferrocene is incorporated to this study. Ferrocene or bicyclopentadienyl ion is a sandwich-like compound known since 1951 Organometallic chemistry is growing interest, especially in the recent decades due to its wide application in the biological and medicinal field. This application leads to a new area called bioorganometallic chemistry. Ferrocene moiety is used in bioorganometallic chemistry due to its stability, biological activity, and application in organic synthesis to prepare new compounds. Ferrocene and its derivatives have played an important role as potential chemotherapeutics. In particularly, considerable attention have been paid to their anti-tumor, anti-inflammatory, antimicrobial, and cytotoxic and DNA cleavage against with respect to cancer cell. Objective: to synthesis some chalcones derivative by Claisen chemical reaction to synthesis new heterocyclic derivatives such as oxazine and tyrosine from various chalcones. Then physical investigation, melting point analysis of synthesized derivatives, purity of the compounds will be monitored by TLC, spectroscopic analysis of these derivatives, example UV, FTIR, and proton and C13 NMR. Evaluation of antioxidant by FRP assay. FRP means spheric reducing antioxidant potential. The methodology, this is the general procedure of synthesis of chalcones. A mixture of substituted acetophenone and 10% of ethanol sodium, 10% sodium hydroxide solution in ethanol was stirred for 5 minutes in a ice bath. To this, ferrocene aldehyde was added and stirred for 1 hour at room temperature. Distilled water was added to the reaction mixture, then stirred for 5 minutes. The precipitate obtained were filtered, washed with distilled water until free of sodium hydroxide and recrystallized from ethanol. The results obtained were analyzed by TLC. Melting point were taken in a digital melting point apparatus. This is the scheme of synthesis of chalcone. Substituted acetophenone, that means 4-methoxy acetophenone and 4-chloroacetophenone, then 4-piperazine acetophenone. That is reacted with the ferrocene aldehyde in the presence of 10% ethanolic sodium hydroxide to form various chalcones. That is 4-methoxy chalcone, 4-chlorochalcone, and 4-piperazine chalcones. Then preparation of oxazine and tyrosine derivatives. A mixture of chalcones react with urea. Urea react to form oxazine derivatives. Thiourea react to chalcones to form thiourea derivatives. Urea and thiourea were dissolved in ethanolic sodium hydroxide, was stirred about 3 hours with a magnetic stirrer. This was then poured into 20 ml of cold water with continuous stirring for an hour and then kept in refrigerator for 24 hours. The precipitate was filtered, washed, and recrystallized from ethanol. The result obtained were monitored by TLC. Melting point were taken in a melting point apparatus. This is the scheme of oxazine. Then various chalcones react with urea in the presence of 10% sodium hydroxide ethanol to form various oxazine. That is chloro-substituted oxazine and methoxy substituted oxazine and piperazine substituted oxazine. That is denoted by 1A to 3A. Then this is the general procedure of the synthesis of tyrosine, same as the then antioxidant activity. I have identified FRAS assay. FRAS means ferric reducing antioxidant potential assay. The reaction mixture was incubated for 30 minutes at 37 degrees Celsius in a water bath. Then the absorbance of the samples was measured at 593 nanometer. A sample blank reading using acetate buffer was also taken. The difference between sample absorption and blank absorption was calculated and used to calculate the FRAS value. In this assay, the reducing capacity of the plant extract test was calculated with reference to the reaction signal given by the Fe2 plus solution. Then FRAS values were expressed as m mole Fe2 plus per G of sample. All the samples are measured were done in triplicate. Then conclusion, result and discussion. All the synthesis compounds were characterized by TLC, melting point elemental analysis, UV, IR, and proton and C13 NMR spectroscopy. Analysis indicated by the symbols of the element is very close to theoretical value. The compounds were evaluated for antioxidant activity. The result of the antioxidant values expressed as IC50 with spheric reducing antioxidant potential assay. This is the table. Out of 3 compounds, FRAS method, Compound 3A, that is suppressing substituted oxazine, IC50 value 165.083 μm, and compound 1A, that is chlorosubstituted oxazine, IC50 value 193, 93.83. Then compound 3B, that is suppressing substituted thiophene, the IC50 value 231.034 μm. Then compound 1B, that is chlorosubstituted thiophene, IC50 value 240.386 μm. Then compound 2A, that is methoxy substituted oxazine, IC50 value 277.927. When these are compared to the standard ascorbic acid at 518.101 μm. However, compound 2B is the methoxy substituted thiophene, so its IC50 value at 1123.82 μm when compared to the standard ascorbic acid at 518.101 μm. Then conclusion. The antioxidant properties of the synthesis test compound of oxazine and thiophene. When tested using FRAB assay, the compound 3A oxazine give better antioxidant activity for both oxazine and thiophene. However, the evaluation in vitro method showed that the test compounds such as 1A, 3B, and 2A had maximum antioxidant properties. These methods have given us insight and the antioxidant profile on a few of the test compounds, test which will further provide scope for screening other related activities such as antimicrobial, anti-inflammatory, cytotoxic, and anti-cancer activity. Thank you.
So, thank you, Ms. S. Avibindu, and
thank you, sir.
You have very well maintained the timings, finished well in time. So, I open the session for 1 or 2 maximum questions, if anyone has.
Yes, sir.
Any questions from the audience? So I think there is no question from the audience, and I just want to ask you about the Tha genes. You have written the oxagenes and Tha genes.
Oh, okay.
Can you throw some light on Tha genes? What do you mean by Tha genes?
That is, chalcones react with thiourea to form tyrosine, sir.
So you have thiourea, then you call it Tha genes. Am I right?
Tyrosine, yes, sir.
But shouldn't we call it thiogenes instead of Tha genes? We should call it thiogenes.
Tyrosine, sir.
Because I remember Thagene word is also used for some medicines.
Oh.
So oxagenes
yes,
and thiogenes would be the better word. Okay.
Oh, okay, sir.
So thank you very much, Ms. S. Avibindu, for your presentation. Thank you.
Thank you, sir.
So now I move to the next speaker. But again, I would recall and remind Ms. Pavandeep Kaur, if she is here.
Yes, sir, she is here.
Pavandeep, are you ready for your presentation?
Yes, sir. Yes, sir. Sir,
So
am I audible?
Yeah, you are audible very much.
Ji,
but
okay, sir.
You please share your slideshow.
Ji, sir, I am sharing.
Yeah. So Pavandeep Kaur is a research scholar of Department of Chemistry, University of Kashmir, Hydrogels, Srinagar, and she is going to speak on interfacially engineered Please mute the mic. Pavandeep Kaur is going to speak on interfacially engineered microemulsion loaded biopolymeric hydrogel capsules, that is a novel food grade delivery vehicle for stabilization and protection of long chain polyunsaturated fatty acids against peroxidation. So I invite Pavandeep Kaur and request her to share the screen.
Sir, I'm not able to share it. Sir, how we have to share it? Firstly, we have to click on that arrow.
Yeah, you have to
After
click on that arrow.
Ji,
Yes.
sir.
Did you click the arrow?
Yes, sir, I have clicked it. After then,
What is coming in your screen?
sir, your entire screen, a window and a tab. Only three
Yeah,
options.
then click the share. Then click the share.
Sir, there is no option for share.
Yeah, that is share on the screen. You see in the down.
Where, sir?
That is share.
Sir, there is no option of share.
Yes.
You have to press on the window option,
Okay.
Pavan.
Ji, ma'am.
Press on the window option. Yes, press on the window option after clicking on the arrow. Press on the window option, and then you will get two different tabs and press on your screen which you want to share.
Yeah, it was.
Okay. Window.
First, you click the arrow, then click your entire screen, then click the share.
Sir, actually the share button is not being clicked here. I don't know why. What is the problem? What is this?
So, okay, in the meantime, you prepare yourself and, I can't waste the time.
Okay.
I will call you at last.
Okay, sir.
So get ready for the last.
Okay.
Okay, Pavandeep?
Ji, sir.
So now we move to the next speaker, Mr. Pavan Kumar. Is Pavan Kumar hearing me? Pavan Kumar, Virender Kumar.
Sir, Pavan Kumar is not in session, I guess.
Mr. Pavan Kumar, Virender Kumar, Navpreet Kaur, Sheikh M. Mobin, Paramjeet Kaur, and Kamaljeet Singh. So I think there is no one present for this paper.
Sir, good afternoon.
Good afternoon.
Sir, I am Dr. Yashpal.
Okay.
My presentation is in this session, sir.
Your presentation is in this session, as I know.
Yes, sir. What is my serial number, sir?
Your serial number is 8.
Okay. Thank you, sir. Thank you.
Yeah. So again, just a gentle reminder for Pavan Kumar. So Pavan Kumar is not available. Hence, we move to the next speaker, Asadullah Khan. Is Asadullah Khan is here?
Sir, it's Rabia Kausar.
Yes, sir. Rabia.
No, there is one paper which Asadullah Khan, Jamir Mirza,
So
Mohammad
maybe
Salim,
Sir-
overlapping of name at
Sir,
your
Rabia,
Mohammed-
sir, I am.
Mohammad
I am here,
Riyad,
sir.
Fatima Parveen, Atiya Said.
Yes, sir.
So
Sir,
presenting
Rabia
author
Kausar
is
is here.
Rabia Kausar.
So Rabia Kausar is not mentioned there.
So actually in your schedule there may be some overlapping of names or maybe something missing. It's Rabia Kausar is the presenting author.
But it is not written here.
So it's Rabia Kausar, Mohammad Salim, Mohammad Sadiq, Asidullah Khan,
Yes,
Samir
yes.
Mirza, Mohammad
Yes.
Riaz, Fatima Parveen and Atiya Sayed.
Okay, so Rabia,
Yes, sir. Good morning, sir.
good morning. So you are here to present
Yes, sir.
the topic carbon nanotubes.
Yes, sir. Yes, sir.
Okay, okay. Are you ready for presentation?
Yes,
Rabia?
sir. I will
So,
share
okay,
share
now,
the.
so now
I
I
want to
invite
share
you.
my screen, sir.
Yeah, you try to share it. In the meantime, I am introducing yourself. So, to you, as Rabia Khan is
Yes.
going to present the paper on carbon nanotubes modified chitosan grafted polyols nanocomposite hydrogels, and
Yes, sir.
she's from the Department of Chemistry, PG College Rajouri,
Yes.
Jammu and Kashmir. So
Yes.
now I request to Rabia
Yes, sir.
to share the screen and present her work as the title mentioned. So
Yes,
I
sir.
think you are trying to give from the mobile phone.
Yes, sir. Sir,
Okay.
I want to share my screen, but stop
How
sharing
can
it.
how can I help you?
Sir, I share it. Okay, sir. 1 minute, please.
Okay. That's that's a big
Share screening, start sharing. Meet will have access to all of the information that is visible on your screen. Yes.
Go to the arrow which is upward. Yes, now it's coming. It's coming. You are sharing your screen with everyone. First what you do, first you open your presentation,
Okay, okay, sir.
then you share the screen.
Sir, I will.
First you open your presentation
Okay, sir.
in your mobile. Yeah, this is coming now.
Sir, you see, sir, can all the persons see my screen?
Yeah, of course, if I can see, then all can see.
Okay, thank you, sir. Sir, I want to start.
Yeah, can you go to the slide mode, slide show,
Slide mode, sir. I can't be
slide show.
because I use cell phone screen first time. I
The
use
slideshow is not available in cell phones.
yes.
Okay. You go to the next slide first. Let's see.
Yes, sir.
Yeah. Okay, that's okay. It works quite a bit.
Ma'am, can you zoom it? Zoom it out?
Zoom it. Mm,
No.
sir, view
Uh,
mode. Add
I think it's better now.
Okay, okay. Yes.
You can
myself
go
is.
with this.
Sir, can
You
I
can go.
start?
Yes, start please.
Myself is Rabia, Dr. Rabia Kosar, PhD chemistry from Jamia Millia Islamia. Today I want to present paper presentation entitled Synthesis and Present Characterization of Carbon Nanotubes Modified Chitosan Grafted Polyol Nanocomposite Hydrogels. These are the graphical representation of various biopolymers and nanoparticles like multi-wall carbon nanotubes, graphenes, which were used for the preparation of nanocomposite hydrogel films, gels with synergistic properties like these hydrogels are biocompatible, biodegradable, and shows very stimuli responsive and shows mechanical reinforcement. Okay, sir. Hydrogels are the three-dimensional hydrophilic polymeric network which have the ability to imbibe excess amount of water due to the presence of hydrophilic functional groups in them like amide groups like carboxyl, hydroxyl in their polymeric chains. Hydrogels have existed for more than half a century, which provide the reports in the literature by Wisterle and Lim in 1954 to 1960. Yes, sir. Okay. Yes. They have the ability to transport the materials and easily can be modified by using various cross-linkers, oleopolyol, like vegetable oil-based material, and they are stimuli responsive. Various biopolymers which can be used for making the hydrogels films with desirable biodegradability and biocompatibility. They show highly swelling ability due to the presence of highly cross-linked network structures, and their swelling properties can be attributed due to the highly thermodynamic affinity towards various solvents. These properties can be adjusted through the introduction of various cross-linkers via covalent bonds, physical interactions, through intermolecular and intramolecular interactions. These hydrogels shows good capillary actions, osmotic pressure, and water diffusions. The concept of smart hydrogels with their responsive toward external stimuli, including temperature, various pH, ionic concentration, light, magnetic fields, and electric field. This results in the formation of enormous potential of these hydrogels, which we can use in advanced technological applications like in drug delivery, which is an active area, which is an active research of the area. Many novel hydrogels with drug delivery applications has been fabricated to fulfill the ever-increasing demand of the pharmaceutical industries. These are the various hydrogels on the basis of the classification, like on the basis of source. There are synthetic, semi-synthetic, and natural. Hello?
Yeah, you can continue. You can continue.
Yes, ma'am, you are audible.
Okay, I expect that I dropped. Okay, there are on the basis of polymer compositions, hydrogels can be classified into different types. That is homopolymeric hydrogels, which are obtained from the single species of monomer. Means there is a basic structure unit comprising of only single monomer. Copolymeric hydrogels are composites which we can use two or more monomeric species, in which one is at least hydrophilic polymers. And last one is copolymers, which copolymeric hydrogels obtained from two or more monomeric species, which are arranged in random or alternating configurations within the polymeric network. And last one is interpenetrating polymeric hydrogels, which are the smart class of the hydrogels, and which mostly the scientists and lot of the literatures are present for interpenetrating polymeric network, which we use the synthetic polymer as well as means the blending of natural and synthetic polymers on the basis of configurations, where we can classify the hydrogels on the base amorphous hydrogels, means non-crystalline, semi-crystalline, and crystalline type. On the basis of physical arrangement, on the cross-linker, there is two types of cross-linker, mean chemical and physical cross-linkers. Chemical cross-links have permanent junctions, while the physical cross-links are temporary junctions like hydrogen bonding and many other interactions. Physical appearance means we can obtain the hydrogels in the form of films, gels, or semi-spheres. On the base of network, electrical charges, there are non-ionic, ionic, or amphoteric, etc. So we can discuss the biocompatible polymers. Natural, where we can use, I can use these biocompatible polymers for making for the synthesis of hydrogels. These are polysaccharides, carbohydrates, modified cellulose, X means hydroxyethyl cellulose, hydroxyethyl, polyethylene glycol, etc. Polysaccharides means chitosan, guar, and many other natural polymers, starch, etc. So chitosan is a linear polysaccharide comprised of glucosamine and N-acetyl glucosamine units, which are linked by 1,4 glycosides created by the deacetylations of chitin at acidic medium. So last one is the biomedical application of nanocomposite hydrogels, where we can prepare the hydrogels and used in various biomedical sciences like in bone regeneration, in tissue engineering, in various type of sustainable drug delivery, in dental application, in plastic surgery, and many more. So where we can use the hydrogels and nanocomposite hydrogels. These are the two different hydrogels where we can't use the nanofillers, plain hydrogels. And in nanocomposite hydrogel, we use the nanoparticles, which are size ranging from 50 to 100 nanometer, 10 to 100 nanometers. And these are the various feed composition of hydrogels, obtaining hydrogel films, where we can use chitosan, acrylonitrile, polyol, bisacrylamide, and multi-wall carbon nanotubes. We can prepare the plain hydrogel films and multi-wall carbon nanotube modified nanocomposite hydrogel films. In these, firstly, we can use for making the aqueous solution of chitosan, followed by the addition of acrylonitrile, polyol, N-methylene bisacrylamide by using simple solution blending methods. Where the what is the medium? Initially, chitosan solutions were prepared and then followed by the addition of various other precursors. Reaction mixture was stirred for 6 hours at 25-degree temperature, means at room temperature, on a magnetic stirrer. The synthesized hydrogels were poured further in the glass plates at room temperature so that there is a completion formation of film. We can still wait until the constant weight of the films was obtained. Sir, everybody is hearing me? Hello, sir.
Yeah, it's okay. Go ahead, please.
And we can use the various permissible limit of multi-wall carbon nanotubes, which we use the pre-polymeric mixtures followed by the sonication for 1 hour to ensure that there is a complete dispersion of multi-wall carbon nanotube, followed by the further stirring on the magnetic stir for 6 hours so that plain and nanocomposite hydrogel films were obtained, and we can still wait for the complete stability of nanocomposite hydrogel films. So when we check the stability of these films, we can separate from glass plates. On the basis of these compositions, we can discuss about the structure and stability of nanocomposite hydrogel films. The multi-wall carbon nanotubes and polyol play a crucial role in improving the stability and mechanical strength of nanocomposite hydrogel films. Here we see the reaction schemes which I can use for the preparation of cap, means these are code which I used, and N-cap nanocomposite hydrogel films. There is the interactions between carboxyl, hydroxyl, and amine group of chitosan and CWH group of multi-wall carbon nanotubes, OH of the polyol, which are interact with each other by the hydrogen bonding, and there is the particular interactions occur between them. On the basis of their interactions, the interaction between different modes of nanocomposite hydrogel films can be attributed to the ionic cross-linker between amine group of chitosan with hydroxyl group of polyol and CWH group of multi-wall carbon nanotubes, which I further discuss. These are the digital pictures of prepared nanocomposite hydrogel films. Here we can see there is the image A shows the dendrimer-like structures, and these dendrimer-like structures are obtained by the addition of acrylonitrile and polyol. In structure B, where we can see the black highly cross-linked network structures are formed by the addition of multi-wall carbon nanotubes in them. These are the two different images which I can take when I prepared these films. These are the FTIR spectra of prepared nanocomposite hydrogel films, plain hydrogels, and nanocomposite. These FTIR spectra shows that there is a peak which can be occur at different peaks. I show the peak which can be occur at 1024 in all the cases which assign that there is a ether linkage of the chitosan moiety. The characteristics peak which can be occur at 1647 yes has been assigned to carbonyl stretching vibration of the acetamide group, where the peaks which can be occur at 1600 shows that there is the NH bending of chitosan. The peak which centered at 1378, which shows that there is the amide peak. The absorption peak which can be occur at 2925, 21, and 2861 at different films, which shows that there is the symmetric and asymmetric stretching vibration of CH2 and CH bond. The shoulder peaks, which
Rabia,
can,
ma'am?
yes.
Pandey sir is talking to you.
Yes,
Can you
yes,
bind in 2 minutes?
yes, sir.
Can you bind in 2 minutes, please?
Yes, 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 yes. Okay, sir. So these are the OH peaks which can be occur at 3293, and peaks can be shift after the addition of polyol and multi-wall carbon nanotubes, which shows that the naked chitosan peak shows the shoulder peak, hydrogen peak, OH peaks at 3293, and after the addition of these precursor, these peaks can be shift at lower wave number values. These are the optical micrograph of nanocomposite hydrogel films, which clearly shows that there is a dendrimer-like structure, and after the addition of multi-wall, there is the intense black color at different magnification are obtained. These are the ESM micrograph of cap swollen hydrogel films, which shows highly dendrimer-like morphology at different magnifications. These are the same micrograph of freeze-dried after lyophilization of 24 hours, which at different magnification shows the porous structure and highly cross-linked structures of the prepared nanocomposite hydrogel films. These are the samples which shows that after the lyophilizations of these SEM micrographs, which clearly show the rod-like structures, means there is a presence of multi-walled carbon nanotubes. And these are 10 micrograph are used for the obtaining the size of the multi-walled carbon nanotubes, which are dispersion in the polymeric matrices, which reveal that there is the spherical size of the particle multi-walled carbon nanotubes ranging from 50 to 200 nanometers, and there's a ring-like morphology which are made for the discrete spots of multi-walled carbon nanotubes. These incorporation of multi-walled carbon nanotubes in hydrogels, which can be considerably improve the mechanical properties of nanocomposite hydrogel films, and shows that there is a strong electrostatic interaction between the functional groups of various moieties. These are the contact surface hydrophilicity of nanocomposite hydrogel. We can when we see the surface hydrophilicity of prepared nanocomposite hydrogel films, we can use the contact angle images by using charged coupled device images. These are the charged coupled device images, which show that there is a combination of hydrophobic and hydrophilic material during the processing of hydrogels, induce some interesting properties in the prepared nanocomposite hydrogel films. The contact angle value of CAP4 is 57.44. After the addition of multi-wall carbon nanotubes, the hydrophilicity are slightly decreased after the addition of, but because hydrophobic character, when the contact angle values exceed 90 degree, it shows hydrophobic character. When there is a value ranging from 1 to 90, it shows hydrophilic. My material is hydrophilic material, so the values are below 90 degree. These are figure second shows the contact angle and surface energy value. As we increase the contact angle, the surface energy can be decreases. So next is
Please bind. Please bind.
Yes.
Please bind.
Okay. These are the digital.
It's already over time.
Okay, sir. These are digital photograph of various nanocomposite hydrogel films, and it shows highly tensile strength. These are the swelling ratios of nanocomposite hydrogels. When we add the permissible amount of multi-wall carbon nanotubes into the films, it can enhance the swelling properties of the which we used at different pH. These are the degradation curves of various nanocomposite hydrogel films for 6 months to show their biodegradable behavior. These are the cellular viability of different nanocomposite hydrogel films at normal human embryonic kidney cell lines, and shows that there is the prepared films are biocompatible in nature, and which can be further used for various biomedical applications like drug delivery, etc. Conclusion. These are the conclusion of prepared nanocomposite hydrogel films. It can be synthesized by solution blending method, and we can use the various spectroscopic techniques and various other, and it shows that after the addition of optimal percentage of multi-wall carbon nanotube in polymer matrices, which can enhance the stability, mechanical, and swelling properties. The test on normal human embryonic kidney cell lines and various hydrolytic and solubility test shows that these are the biodegradable and biocompatible nature of the film now of these material. Thank you.
So
Thank
thank
you,
you, Rabia Khan.
Yes.
Before opening house for question, I personally want to say 2 points, Rabia,
Yes, sir. Yes.
to you that your work seems to be very interesting,
Yes.
and but the problem is that in some cases we can't help you. You
Yes.
have to help yourself.
Yes,
So,
sir.
but we couldn't see a good presentation because you could not come on to slideshow, because your some of the graphs, some of the pictures were seems to be of very interest for all the audience, but it could not be well presented as it should be. So please take care in future that
Yes.
you have done a very hard work, and that the slide seems to be very good, very impressive.
Thank you,
But
sir.
because of I think mobile and the technology which you are not aware of, so
Sir, light is not there. I living very far from areas, and
yes, yes.
this is
But
the issue, sir.
it would be of more interest if we have the rather clear slide. So
Sir,
only one
next time I
question.
will try my best.
Now house is open for one question.
Yes.
Hello, ma'am. Hello.
Yes. Yes.
Yes,
It's
please go
very
ahead.
nice presentation, ma'am. I have one
Yes.
question. What is the
Yes.
part of chitosan in this present work, ma'am? And what type of
Sir,
polyols are used in this work?
Sir, chitosan is a natural polymer we are used for the preparation of hydrogel films or hydrogel gels. It is a basic means I prepare the hydrogels by using these polymers. But it is the main.
So why you have
main
selected chitosan? Other
Sir,
polysaccharides are
I
there,
see
no? Like starch,
properties.
bergam.
Yes, sir. Sir, learned various literature about the chitosan when I studied. Then I used because it is biocompatible and biodegradable and various other synergistic properties in chitosan. Here that I can use because when I prepare the hydrogels, it further can be used in drug delivery applications. I further studies this material in drug delivery. So I use natural material. That's why I can use.
Madam, is there
Yes.
any
But
types of other interaction instead of hydrogen bonding?
sir, as per my concerning is that it is the it is the electrostatic interactions instead of hydrogen bonding, that is amide and OH of amide group of chitosans can be interact with the OH group of polyol.
Which type of polyol you have used, ma'am, please?
Sir, I used vegetable oil-based polyol by using standard method, which where all the lammates of mine, senior lammates, use the standard method, and I also followed their method and prepared the polyols,
Okay.
which
Thank you
I
very much.
choose.
Thank you very much.
So thank you very much, Rabia, for good presentation and wonderful interaction.